God, there we go. It's gone.
Okay. Hello, we're Team So Fresh, So Green. The goal of our senior design project was to create a product that automated data collection and processed data for researchers working in greenhouses. The name of our product is Fern. Since our target audience consists of plant researchers who do not have any electrical engineering background, our product does not require technical knowledge to use. Plant researchers are responsible for monitoring and collecting a variety of data, such as temperature, humidity, or light, from many plants at a time. However, since most insight is gained by analyzing the data, having an automated data collection system frees up time and resources for researchers to focus on the analyzing portion of research. To help with the analyzing, Fern also provides support for basic statistical analysis methods with room to add more. Once the collection and analysis of data is done, Fern can turn that data into presentable formats. This way, the researcher can collect, analyze, and present data all on one platform. Research can be done on many different plants and in a variety of environments. For this reason, Fern is integratable and adaptable to different greenhouse setups. The user can choose what kind of sensor and how many of each kind. The user can also set the schedule for the data collection to suit their research needs. After we nailed down what we wanted to do, we came up with 5 different ways of implementing it. In order to decide which one was the best, we came up with a decision matrix. The first column from the left consists of the factors we took into account. The second column consists of how much importance we gave to each factor. As you can see, we ranked ease of use as the most important factor and availability of documentation as the least important. The final row on the bottom shows the score that we got for each design. Design 1 in the third column had the highest score according to the decision matrix, so we chose to go with that design to implement our idea.
Since ease of use was an important factor for us, we envisioned Fern to have sensors that had the same functions as a USB and that you can easily plug it in and out of our product. This way, we would also be able to make our sensors interchangeable, allowing the user to pick out sensors that they need the most for the research. Here in the top image, you can see that there are a wide variety of sensors to choose from, but we wanted to narrow them. We chose to specifically implement sensors that measured light, temperature, and water pH because those were the ones that the researchers had mainly preferred. To give researchers more options, we decided to add a few other sensors to Fern as well. Another aspect of our product that we had to take into account was determining whether we wanted to make Fern wired or wireless. We thought about using Bluetooth or Wi-Fi on the sensors so that the user can freely place them anywhere within their greenhouse. But considering the cost and unreliability of using Bluetooth or Wi-Fi, we decided to go with a different alternative. We chose to mainly use wires in our product, but still have some wireless capability by storing data into a micro SD card that can later be transferred to our software program.
In addition to providing statistical analysis, we're also giving the user the option to graph the collected data. Examples of the types of graphs that we are offering are a bar graph, scatter plot, and a pie chart, etc. With giving the user options of what type of graph they would like to view their data on, the user can easily implement the graph into their research. To achieve the goal of flexibility and scalability, as well as maintaining low costs, we chose to implement open source software into Fern. This also reduces the need for a specialized engineer to scale Fern's software and hardware abilities, as there is ample information for the chosen open source software platforms we chose. By building Fern on top of our open source software platforms, this also allows the user capability of scaling our product to their use cases for free.
Our ultimate goal was to keep things as simple as possible so that the user will only be required to plug in the microcontroller to the power supply and the computer to get the commands. By making the setup of the product as straightforward as plugging in a USB, the need for knowledge of circuit is eliminated and allows the user to utilize Fern. For ease of use, we wanted to create a graphical user interface for the user because the Arduino doesn't come with one. Since JavaScript has the most native support for graphical elements and is the language used to build most modern websites, we ended up choosing it to write our program. When it comes to standards, an important one that we used was FAT32. FAT32 allowed us to format our micro SD card, which stored the plain data. FAT stands for File Allocation Table, and FAT32 is a standard which controls how data is stored and retrieved.
Looking at the standards on the software side, we chose to use Electron. It's not a standard per se, but it does give us a robust open source platform to build our user interface on. Popular softwares such as Slack and Discord are developed using Electron. Moving on to the actual product, we want to tell you where we were before the stay-at-home order. Before the stay-at-home order, we were working on the UI software. We had also coded and tested most of the hardware components individually, and those hardware components consist of mainly data sensors. Unfortunately, we never got the opportunity to assemble our hardware onto one Arduino board, but this is what we anticipated it would look like. For the next part of our presentation, we will show how each data sensor works and demonstrate the UI.
And